Okay, you guys, so this will be the last section from chapter 8 that we cover. So this is further graphing of the quadratic functions, and there's quite a bit that we have to cover in this section. These are the objectives that the book says, but this is kind of very vague, so I'm going to add a little bit to this for A, B, and C as we go. So write quadratic functions in the form y equals a plus x minus h squared plus k. This is a typo right here. So they mean y equals a times x minus h squared plus k. I think the computer just read its own writing wrong. So this is what I call vertex form. Okay, so this will allow us to find the vertex very easily because the vertex is just h comma k. Okay, then it says for part B, derive a formula for finding the vertex of a parabola and then find the minimum or maximum value of a quadratic function. So we're gonna, for part B, we're just gonna use the formula. And then in part C, we will learn how to use the calculator to find minimum or maximum values as well. And if it is needed, I will make a separate video on just how to use the calculator for this stuff. Okay, so quadratic functions. We know that the graph of quadratic functions is a parabola. If the quadratic is written in the form f of x equals a times x minus h squared plus k, then we can find the vertex h comma k and graph the parabola. So here's the thing. Once again, this is the formula I was telling you guys about. So what we're going to do is we're going to try to get that form, because if we have the form, vertex form, we know that we can find the vertex of a parabola, which is one of the most important aspects of a parabola. So it says find the vertex, axis of symmetry, and any intercepts, and complete the square on x. So this is actually a lot of information that they're telling us. And then they want us on top of that to complete the square. So they're asking for quite a bit from this problem. So what I'm going to do is I'm going to have to take this problem and we're going to come back to it. I want to give you a nicer problem. Okay, so let's come over here and let's do new example, because that one starts off too hard and then we'll come back to that one. Okay, so new example. Okay, so if I give you f of x equals, and then I say negative x squared minus 10x minus 9. Okay, so let me see if this is the one I want to do. Okay, so whenever you are doing completing the square, that means that completing the square, the way I'm going to teach you guys, or you may have already seen it last semester, the way I do completing the square is if you're given f of x equals ax squared plus bx plus c, and don't worry too much about the plus or minuses. If you have it in this form, you want it to be like this. You want it to be f of x equals x squared plus bx plus c. So the way I'm going to teach you to complete the square is there must always be a 1 in front of the x squared term. Now, there's more than one way to do completing the square. This is just the way I'm going to show you guys. If you have an alternate method that you're good at, just let me know. But this is how I teach it. So what I'm going to do is for this particular problem right here, I know that I need a positive 1 in front. So what I'm going to do is I'm going to divide everything. So this is going to be f of x divided by negative 1 equals negative x squared minus 10x minus 9. And I'm going to divide each one of these terms by negative 1, including the f of x. So now I have this new situation. Let me double check something. I have this new situation where I have negative f of x equals x squared plus 10x plus 9. Now, the thing is, when you're doing completing the square, you always take whatever b is, okay, and you take half of it and square it. So you do b divided by 2 squared. This is how you find that perfect number that will complete the square. So in our example, we have our b is 10. So I'm going to take 10 and divide it by 2 and then square it. So this will be 5 squared, which is equal to 25. Okay, so that means what I what I want to do also is, now you have two choices. There's, like I said, there's a bunch of ways to do this, but normally what I like to do is I like to move anything without an x to the other side. So I'm going to -9 there. So I'm going to have negative f of x minus 9 equals x squared plus 10x. Now notice, and then I always just say plus blank, okay? So my blank is what's very important right here, because this goes right there. So I'm gonna put a 25 here, but notice I just put a plus 25 right there. So you have two things you could do. You could then minus 25 on that same side, because if I give you $25 and then take 25 back, I did nothing, right? So if I do that, that's one way. Or you could put a plus 25 over on the left side. So over here, I put a plus 25, and over here, I put a plus 25. So both sides of the equal sign have a plus 25. I'll probably just do that because that's a little bit easier, I feel. So now I'm going to end up with negative f of x. Now, plus 25 minus 9, that should be what? Plus 16? Let's see here. Yeah, okay. Equals x squared plus 10x plus 25. Now, the good news is this right here should be factorable in a very nice way because you made it a perfect square. So now we have negative f of x plus 16. Let me just double check something on my calculator. Okay. So negative f of x plus 16 equals, now I'm going to factor this, x plus 5, x plus 5 quantity squared, because if you take x plus 5 and you square it, you'll get x squared plus 10x plus 25. So that is the perfect factors. Now I have to go back and turn it into, what was it? This form, right? I want the original, I want it to look like this, as plain old f of x. So I'm going to come over here. Okay. And what I'm going to do is I'm going to start moving things back over and get f of x by itself. So now I'm going to minus the 16, minus the 16. So this will be negative f of x equals x plus 5 quantity squared minus 16. Then I'm going to divide by -1, divide by -1, divide by -1. So let's go over here. So now I have f of x equals negative x plus 5 quantity squared plus 16. Okay. So we now have vertex form, right? So this is now vertex form. Okay, so what I'm going to do now is I'm going to find the vertex, because that's what it tells me how to do very quickly. So the vertex is equal to -5, because you always take the opposite, and then plus 16. Okay. We know that it is a downward opening parabola, since a is less than 0, right? Because this is my a right here, that -1. That's really a -1, and that's less than 0, so we know it's downward facing. Now, they also wanted to know x-intercepts and y-intercepts, right? So for this previous problem right here, they said find the vertex, axis of symmetry, and any intercept. So we need to find the x and y intercepts. So let's first do the axis of symmetry. So axis of symmetry. We know that that is x equals -5, right? So let me just plug something in on my calculator real quick. So negative parentheses. I'm going to plug this into my calculator just to verify everything. Oops. Yeah. So now what I need to do is I need to find the x and y intercepts. So you guys should remember that in order to find x-intercepts, okay, so find x-intercepts, let y equals 0, right? So that's how you find x-intercepts. So we're going to go back to the original. Normally I go from the original. So we have negative x squared minus 10x minus 9 equals 0. So negative x squared minus 10x. Why can't I write right now? Minus 9 equals 0, right? So I'm going to let this equal 0. So you take this and you set it equal to 0. Now I can factor out a negative and divide everything by -1, and I will get x squared plus 10x plus 9 equals 0. And all I did was, in case you're wondering, I just divided by -1, divided by -1, divided by -1, divided by -1. Okay, so now we factor this, x plus 9 x plus 1 equals 0. So x equals -9 and x equals -1. So that means my x-intercepts are these points. So x-intercept is -9, 0 and -1, 0. So there are two coordinates on the graph, or 2 points on the graph where I have that my graph crosses the x-axis. So now we come down here. We do the same thing, but now we do y-intercepts. Now y-intercepts are much easier, right? Because for y-intercepts, let x equals 0. Well, that's really nice, because if we come up here, that means that this would become 0, right? This would become 0, right? And we'd just be left with -9. So the y-intercepts with parabolas are normally pretty easy. So we're just going to say that it is 0x and then -9, my y coordinate. Okay, so that's telling me where it will cross the y-axis, right? So we have 0, -9, 0 for our x and -9 for our y. Okay, so far so good. All right, so now let's graph it. So now we're going to take and do a little graph. And again, it's going to be not perfect because of human error in drawing, but we kind of will get the general idea. I'm going to go by 2s just to make it kind of fit on the graph. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So let's go -10, -10, 10, and 10. Okay. So let me see here. Where's our vertex? Unfortunately, our vertex is -5, 16. So that's not good. So I have to go over -5. So here's -2, right? -4. So -5 is here somewhere. And then 16 would probably be like up here, right? Like somewhere right there. So that's -5, 16. So that's my vertex. And then it's going to cross the x-axis at -9, 0. So that's right here. And at -1, 0. So that's right here. Okay. And then we know it's going to cross the y-intercept at 0, -9. So that's right here. So now I can draw a pretty good graph. Oops. I'm just doing my best to try to graph it. It's not going to be perfect. Okay, and that's what my parabola would look like. So this is how you can graph a parabola, by getting all of this information, the y-intercepts, the x-intercepts. You know, if I zoom out a little, you can see how much work we actually did. But this shows that I know a lot about a parabola. I completed the square, I did all this stuff. So now we're going to come over here and we're going to do something similar, but I'm not going to go into as much detail because I just showed you how to do everything from scratch.